And so what I've come to talk to you about today is using machine learning to analyze documents. It's a very interesting use case. My background is in consulting, and so coming out of that consulting work, we had an idea. We went to a client and said, oh, we should turn this idea into a product. And so that's what we're going to talk about today. Before going into all of the deep details, let's just talk about the high-level idea. It's natural language processing. And so what we're talking about is discovering risk and bad stuff inside a big data set of documents that humans have trouble going through. And so specifically, we're saying you're a company, a Fortune 500 company, big company, bank, government, and you would like to find what bad things did someone in my organization write down that maybe I forgot to fix, that I didn't remember is a problem. And so it turns out this is currently done by humans in office buildings. They go through paperwork, or sometimes they don't go through that paperwork because they're too much and they select areas of that paperwork to assess. And so this is something screaming out for automation with computers. And it turns out that automation requires some artificial intelligence, which we're going to talk about today. So what I want to do in this talk is really two parts. The first is to explain the idea, and the second is to show some examples of what do you get when this works well. So let's start with the first part. What is this thing? Why is this a problem, and what's the solution? And so let's start with the idea. You want to identify risks in these corporate documents. They may be internal secret documents because you're finding bad stuff. You don't want to just let it out there. Or it may be that you're reviewing public documents. For example, banks do something called country risk, where they review a bunch of documents from a country to see how risky it is to operate there. And so it may be an on-prem installation of this AI solution, or it may be in the cloud if you're not reviewing documents that are, if you're a government that are not classified, or if you're a company that are not, for example, client information like GDPR information, like people's names and phone numbers. And so there are many reasons to want to hold close the bad stuff that you're looking for. And so what is a risk? What is this risk thing that we're looking for? It turns out risk management is a huge area. It covers lots of different types of sentences, from observations to descriptions of threats to process risks. It's a very large area. And what you want to do is take a giant amount of text and pull out the specific things in that giant amount of text that covers many years of data that are risky. You want to find this stuff. So that's our goal. Now, let's look at some specific examples. We'll just start off by real examples. So the sentence, employees seemed to be unaware of the difference between confidential and anonymous, sounds entirely reasonable, but it's a risk. The risk is that by employees not being aware of what's confidential versus what's anonymous, they're going to leak information. There could be a data breach. This could be bad. Now, unfortunately, we can't use keywords because nothing in here says risk. You just have to read the sentence and understand it and then go like, oh, risk. Another example, the audit team was unable to confirm destruction due to lack of historical information on 2 projects. This is at least an example where they're telling you that they don't know something. Sometimes there's an absolute absence of information. There's no sentence at all. It's just you need to remember that they didn't say something, and that's a risk. And so keywords are not going to help us here. We really need context. We need to read and understand the sentence in order to pull out from the large stack of papers that's infinity high, where were the risks inside the company, in their documents. So why do we even care to find risks? Well, risks evolve over time from something that sounds bad to something that is bad. So first you have a note that says, there's some devices, no one's looking after them. And then a couple years later, someone else notices like, hey, this stuff is not tracked. What are you going to do? And then someone again says a couple of years later, 6 years later, whatever, hey, I don't even know where these devices are anymore. And then there's a data breach. And so a risk in 2008 becomes a data breach in 2020. these things take a long time to slide from bad to really, really, really bad. And so why not try and catch them? These are things that the guy who wrote the original report or the girl is gone, they retired. But you still need to find and track this stuff. And humans don't do a great job of this. And so the first problem is trend awareness, seeing where things are going over time. This picture is simplified. In reality, how do you actually do it? So another problem is human bias. You have different people that have different definitions for themselves of what is risk. Auditors have frameworks that are definitions of risk. They among themselves cannot necessarily agree. They have different frameworks like COBIT and COSO. But just think about a normal human. A techie person will say, encryption keys are too small, this is a risk. And a business person will say about the same thing, the data is encrypted, it's fine. Versus a business person may say, oh, I see like increased competition, there's some kind of risk happening in our business line. Whereas the technology person says like, there's no technology risk, everything's fine. And so we can't even as humans come to agree what risk means because we're all biased in our own way. We all have our own objectives which inform our definition of risk. Computers, believe it or not, if you give them a big enough data set, are better at flagging risk than people because it has no bias. It's biased to whatever the data set says. And so if you collect data from enough stakeholders, you actually get a more unbiased picture from the computer than you do from a person who reads the documents. And so that's an interesting problem that's out there today. Now, going back to trend analysis, it's very, very difficult if I hand you a very large stack of documents for you to understand that the amount of mentions of some entity, like a company or an organization or a counterparty, a customer, is going up and down over time. Humans are not good at figuring that out in their head, but the computers are great at that. And so we can assess that there's a risk if an important partner or party is no longer being thought about or talked about in our data set. And so that's another issue that we address with this tool. And all these problems are moving towards a solution. So another problem is that our clients are quite large. They're banks, they're governments, and they have data in more than one language. We're going to see later on, there's data in English, in French, that's just Canada. Then you've got German, the Swiss Stock Exchange, Portuguese, the government there. In Brazil, you've got Spanish. We have a banking client that has documents in Spanish. There's all these different languages. And so you can't just make it a model in English. You need some bigger solution in order to address the needs of the client. If you go to a multinational and say, like, I only do English, maybe they're okay, maybe they're not. And so it requires a solution. Another really bad issue is that the humans that do these jobs today do sampling. Now, that sounds bad. It is bad, but that's how it works. What they do is the auditors go to where the money is, let's say payroll, accounts receivable, and that's where they audit because that's where the money is. But maybe they miss data breach, the non-sexy parts of the organization where bad things can also happen. And the reason they do this sampling-based audits is because people's time costs money. And so this is already a process, this process that happens today is being done inefficiently by humans. And so there's an opportunity for improvement here to make sampling go away. The real risk is that someone said something that no one ever looks at again because the title of that document didn't sound cool. And so nobody reads the report for the next 10 years. And that could be a real problem if there was something important and subtle in that report. Another problem, and there are many more, is that audits done by humans are very slow. They'll have things like the annual audit meeting, and you're like, wait, risk is immediate, it's not annual. And they go like, well, it's done by people, and they have to aggregate their reports, and the department has to come up with a summary report, and it has to be reviewed. And so this process that's being done in large organizations is hilariously inefficient because it's done by people who push paper around. And so when there's an immediate threat or there's a trend happening, it's very difficult to see when you only look at it once a year. Even if it's the core thing that you look at, you're not necessarily looking at it with a quick turnaround. The standard in the industry is to do annual and sampling. And so that tells you a lot. When you try and assess this data with the computer, you immediately run into some problems. These documents are not meant for computers to read. They're meant for people to read. And so you have to use additional capabilities to convert the data into sentences. You can't break the data by splitting in, like by the period, the dot character, because they pay in US dollars will end up as they pay in U, and then S, and then dollars. But what you want is the computer to know the first sentence is they pay in US dollars. The second sentence is page break, footers, etc. And so that process of extracting data is a whole nother challenge that happens when you try and address this area. There are page breaks on documents, there's footers, there's all sorts of non-ideal conditions because you're dealing with documents that nobody thought would be digitized in this way. Furthermore, you have to understand the surrounding information around the sentence that you look at once you extract it. So if you just look at next she killed them, it seems very aggressive, like, oh, a huge risk. But if you look at the sentences before and after, they provide a lot of context to tell you what's really going on. And if you look at the surrounding sentences, she looked for the processes consuming memory, next she killed them, finally the memory was cleared up. And what that tells you is this wasn't a risk, this is just someone doing their job. It's all good. But you needed to see the broader context in order to assess what's going on. And so taking a larger view of these so many problems, we have large organizations, there are many, many of them, governments, banking, people who care about compliance, and they have too much text. They also, because they have too much text, have stuff in too many languages, human bias, etc., this whole list. And so a holistic solution is needed to solve the higher level problem of find risks that addresses all of these lower level problems, which are all the stuff that we talked about and more. And so it's useful to look at some real examples to see what do you get out from this system when you put documents in. And so the way it works is you take some documents, you run it through our machine learning system that does the text extraction and analysis and storage, and you get like a user interface front-end view. Instead of showing you the tool and doing like a walkthrough demo, I wanted to take a more data science approach and say, like, what kind of insights do you get in like a Jupyter notebook when you run the backend to see like, what is this doing? And so the examples that I want to cover today are from 5 different languages in order to showcase the multi-language capabilities. For each language, we have a different model and a different data set. The reason for that is that multi-language models don't perform as well on this type of task than language-specific models. The reason we think is because the level of the language, as you'll see in a moment, is very high. Auditors don't say, I went to work today. They say long, complicated sentences, especially when they're delivering bad news. So when they're saying, this is a big problem, they don't want to get fired. And so they go to their client, who's the company, and they say, here's our audit report. We'll say it in a nice way, in a nice long sentence way, the horrible things that are wrong with you. And this is also true of internal audits, not just external audits. And so when you're performing an internal audit and you have to hand a document to your boss that says, wow, we suck, you don't want to say that. Instead, you want to say something much nicer, like, here are the opportunities for improvement in 2021. And so the people writing this data are actively trying to cover up the thing that we're trying to uncover. And for that reason, in each language, they're covering it up in their own nuanced way. And so it's helpful for us to have data sets that we train our models on in each of these different languages. Now, we do have a multi-language model for languages not listed here, but they don't perform as well as the application-specific models in their own languages. And so hopefully that's a little bit more clear why. So what I wanted to do here is provide for each of these different languages, starting with English, hopefully no translation needed for English, to provide some examples of actual documents that are in the public domain and sentences that were extracted by the tool where the tool says, this is a risk, you should look at it. And so the end user for this tool could be a CTO of a company who wants to just look around. It could be an internal audit department that's looking to, look for risks to include in their audit, or it could be an external auditor like Deloitte, who we've partnered with to assess their clients' data, to understand within their clients' data where are the risks and to do the external audit. And so on the left-hand side here, you'll see that I've put the year that the document is from to show you that some of these risks are not, this just happened yesterday. It's someone wrote this report 10 years ago. Did anybody look at this in the last 10 years? And so we're talking about a large volume of documents. And so let's look at the first one. We'll look at them one by one to see like what's the wide variety and sampling of cool stuff that the tool spits out when it analyzes these public reports. And on the right-hand side, I've provided like what was the file name, just because it was easily accessible to me and to give you a sense that like this is a real thing. And so one of the things that we see, the first thing, is that the people are using the word password as their password to access some system. Typically what a CTO will receive is a high-level summary in the audit report that says, we have to do more work on information security in order to improve our performance on data breach scores. But they won't get this sentence where someone wrote like, yeah, people are using the word password for their password, because it gets too watered down as things roll uphill. The advantage of using a tool like this is that it actually does expose to you the reality that's going on underneath at the bottom level, the low-level reporting. So here's another one from 2014. There are no recovery point objectives for this department's IT applications. That is a pretty big risk. What that means is, and the tool read the sentence and understood it to say, if something bad happens, you're not going to be able to recover easily from that bad thing. And so that's a risk. And so this is a really good example of where nothing bad actually did happen yet, but the risk could turn into a loss. It could convert into a loss. And that's what the model is trained to do. Not to say something bad did happen, but to identify risks that can become losses. That's the goal of this system. So let's look at another one. These are Canadian government reports. That says the procedures for creating passwords to access this internal loan system is weak, and accounts are not regularly deactivated, making the system vulnerable to inappropriate access. So this audit of this program is saying, hey, people might log into these old accounts that are not deleted and like check account balances, take money, do bad things. This is a risk that could become a loss. Finally, let's look at the next one. Training advice and guidance provided to officers are not consistent. This is a really interesting one. And so this is the employment insurance program. And when people make decisions about who should get money, if they do something bad, discriminatory, they could just point to the training and say, it's not my fault. You guys didn't tell me how to do my job. And so this is pointing to a risk that people misunderstand the training and then do their job wrong, and then everything goes bad. And so it's a very subtle thing that like the model is thinking 2 steps ahead to A becomes B becomes C, and that's a risk. And so these are some nice examples in English. Let's look at Portuguese. I don't know how many of you speak Portuguese, but we're going to look at the translated version to give you a sense of like what is the tool extracting from these documents. And so here's the translated version. These are recent, they're from 2020. So the PMU did not elaborate the risk monitoring plan in the audited year, and the failure to observe this term of reference was verified. This is a very, very nice way of saying something bad did happen, we wrote it down. And so if you read a little bit deeper, even in the beginning of the sentence, it's saying they're not prepared for a bad thing to happen again, and that bad thing did happen. So this is the kind of thing that you want to find when you're reviewing recent documents, which is, let's try and stop bad things from happening again. So let's look at the next one. As a result, there was an absence in the Institute's system of the indication of the human resources needed to carry out each planned action, as well as the measurement of the estimated operational capacity of the IT area. Now, what's interesting, what's going on here, is you see very long, complicated sentences. They're also in the original Portuguese long and complicated to try and soften the blow of bad news. And so what's happening here is they're presenting this saying there was an absence of something. Very, very nice way of saying it. But really what they're saying is you don't actually have a good way of estimating. Maybe fix that. Okay, and so looking at the last one, examining the price survey for electronic auction, whatever, it was found that the amount budgeted by this thing is above the average of the quoted quotations obtained in the market. This is a very, very nice way of saying somebody might be putting money in their pocket. When you see someone buying a hammer for $200 and a chair for $400 and they work in the government, you go like, are they getting half that money back from the person that they're buying it from and putting it in their pocket? And so it's a very interesting phenomenon that you're seeing here across these different languages and different documents from different countries, from different situations, where the model is finding bad stuff. I'll go through this relatively quickly so that we have time for questions. We've got Spanish, another example. And so these two are actually from the same document. And what we see is the first one is about a significant loss to the country because of some storms in 2007. This report is in 2013. And the model says, oh, storms are a risky thing. You should think about that. The next one is from the same report, and it's looking at project execution and saying, these people are estimating a certain amount of time for a project. It's usually a lot more than that. And so don't believe the other part of the document where they're saying it's going to take a year, it could take 5. They're not good at estimating the duration of projects. And it realizes that's a risk that could turn into a loss. Because if your estimate of how long stuff is going to take is wrong, your estimate of how much it's going to cost is wrong, and then you're going to lose money. And so it's kind of thinking ahead. We've got some examples in French, again, Canadian government. Some of these are actually quite juicy. They're pretty interesting. I'm not going to read through every one because like you can kind of see there's a pattern here that, you know, the audit team finds stuff that's bad and reports it. Sometimes it's through internal documentation, not from audits. Sometimes it's the auditors themselves finding bad stuff. And so again, another example in French. Now, this is actually a cool one I wanted to call out. So large volumes of irregular purchases on fuel cards for official vehicles, including duplicate transactions, purchases of volumes of gasoline that greatly exceed the capacity of fuel tanks. And so what they're talking about is people get reimbursed for their gas in this government situation. They go with a giant container to the gas station and just fill it up and go, okay, government, reimburse me. Then they sell someone the gas in order to divert money. So this is kind of a cool idea that it's flagging there's a potential of diversion of money happening here. Like using way more gas than is feasible that person actually used by, you know, buying 5 times a day, that kind of thing. And so interesting. And again, not new, but the question is, did somebody fix that? Is there a process in place now to prevent this or to detect it? So finally, in German, and we can talk a little bit about the customer use cases and stuff. So the German model was actually for Swiss German, but this is a German example. And so in 2011, they said in this external disclosed report, it must be decided whether further risk assessments are necessary. That was in 2011. In the past 9 years, did someone look at that again? It seems like a trivial thing, like, of course they said that. But did they actually like follow up on it in the last like 9 years? That's kind of the process of what you expose when you apply machine learning to these large document sets. So hopefully you've got a sense of what the value of applying machine learning to these large text data sets is to extract like business value for customers. And so this is a pretty dynamic area. We're continuing to develop in this area. We have the platform, we've got it installed at banks and its government clients, and we're going out into the world and applying these capabilities. So yeah, it's we've got plenty of time for questions, and I'm happy to explain to you a bit more about it. If you'd like to hear more, I can set up a demo or whatever. You can reach out to me at this email address. You can look at our website, and some of our customers are disclosed there in press releases.